Today we are starting crash course physics, and its first chapter is units and measurement. In this first chapter, since it's a crash course, we don't have much time to elaborate each and everything. This course is for those who did 1 year program, those who prepared the whole syllabus or studied well in their school exam and want to refine or want to get the final output by the expert. So the whole chapter will be covered in today only, and I will go through each and every small and big concepts, but in a short, or I'll take 1 or 2 numericals also. So straightforward, I'll start with dimensional analysis. Here we'll discuss 3 points. One is dimensions, other is dimensional formula, other one is dimensional equation. I have written in this form, flowchart form, just to tell you the differences between them, because we may often confuse between this and this. Dimensions are the powers quotient raised to physical quantities, such as, for example, if I write length, you may write it is meter to the power 1. So here 1 is dimension. It is of 1 dimension. If I write area, it is meter into meter, that is meter square. So here it is of 2 dimensions. Now, if I write volume, again it is meter into meter into meter, it is meter cube, and it is of 3 dimensions. If I write speed or velocity, as you know, it is meter upon second. So its dimension is 1 dimension in length and -1 in second. Now what is called dimensional formula? When we write in a different pattern the dimensions of any physical quantity in a definite pattern, in a systematic pattern, we call it dimensional formula in a double bracket. For example, M, which you know already, mass is represented by capital M to the power 0, length is represented in capital M to the power 1, T is represented, capital T is represented for second. If we close it in a bracket, big bracket, then this is a systematic manner that this is a dimensional formula of velocity or speed. It is called dimensional formula. Means representation in this bracket in a systematic way is called dimensional formula. Now, what is dimensional equation? If we write this dimensional formula in terms of LHS and RHS, like speed is V, V is equal to this, then it becomes dimensional equation. If we write V is equal to m to the power 0, l to the power 1, t to the power -1, it is called dimensional equation. Similarly, for volume it is L cube. For any other thing you may write like this. It's a volume. Now there are various uses of this dimensional formula equation. Let us begin. analysis. Basically, there are three uses. First, let me again write in flow chart to check the correctness of any physical formula to establish a relation among various physical quantities to convert from one system of unit into other. These are the dimensional analysis to check the correctness of any formula, whether it is correct or wrong, to establish relation among various physical quantities, like time period depends on length and g, so you can establish a relation between them. To convert from one system, like if any unit, any physical quantity has some value in any unit, then what will be its value in next unit? So we'll go one by one. Which one is first, second. I'll explain few on this board only, and then later on we'll go in detail. How to check the correctness of any physical formula? Here, principle of homogeneity works. What it says, principle of homogeneity? In principle of homogeneity, dimensional formula of LHS is equal to dimensional formula of RHS, or only same dimensions can be added, subtracted, or equated. It means if A plus B is equal to C, then A must be having same formula, dimensional as B and as C. So if I have A is equal to B plus C, then I should write dimension of A should be equal to, or it is minus also, dimension of B is equal to dimension of C. It is called principle of homogeneity in this dimension analysis. Now, how to get establish a relation among various physical quantity? Again, dimension of LHS is equal to dimension of RHS will come into picture. I'll explain again with each and every clarity after that. How to convert from one system of unit into another. For example, let me write length is 1 kilometer. If length of a body of any measurement is 1 kilometer, then I may write it in 1000 meter also. I may also write it in 1 lakh centimeter. I may also write it 10 lakhs millimeter. All values are same, but if you look at its numerical value, it is increasing because its dimension, its unit is decreasing. We are using lower units. If kilometer converted into meter, smaller units, number is bigger now, larger now. Meter becomes centimeter, even more smaller, number increased. Centimeter becomes millimeter, this increased. So these values are called numerical value, and this one is called unit. It is numerical value. We call it n into u. You must have seen the product of numerical and unit is constant. And this will help us to solve questions based on three conversion from one system of unit into another. Now I pick few questions based on all these three, and then you will be more confident to solve questions, tackle questions based on dimensional analysis. All of you are advised not to write along with me. In last, you may pause this screen and note it down. So your concentration is very important here. Later on, you can copy it. First, to check the correctness of any formula. For first, I will consider few examples. If S is equal to ut plus half at square is given, now we have to check whether it is correct or wrong. As you all know, this one is correct, but I still have taken this example just to ensure yourself how to check it. And you know its result also. Now, according to law, principle of homogeneity, same dimensions should be added, subtracted and equated. So this because half is a constant, and this should have same dimension. So dimension of S is equal to length, let me write, meter. Now dimension of U into T is meter upon second into second. It is meter only. Dimension of AT square is A is acceleration, which is meter per second square, and T square is second square. So it is meter. Now clearly seeing that this time formula is okay. Parallelly, few examples which are important for competitive exam are exactly through this concept. Consider one example where if x is length, t is time, and F is force. Force is given as A sine kx plus minus and write bx plus minus ct. Then write out dimensional formula of A, B and C. Suppose this expression is given. Since it's a crash course, we have to pick the direct questions which will help you directly in your exam. You know, sine, exponential, e, cosine, all trigonometric functions are ratios. They don't have any dimension. And this one is angle. This one is angle, so angles are ratio. Since sine, they don't have any trigonometric function, they don't have any dimension formula. So left hand side it is force and right hand side it is A, and sine this one is not having any dimension, so A must be equal to F dimensionally. So dimensional formula of A must be equal to F. If I write dimensional equation, I should write force. We all know it is mass into acceleration, and acceleration is mt minus 2. So dimensional equation or formula of A is mt minus 2. Similarly, since this is angle, don't have any dimension, no dimension means m0, l0, d0, that is 1. And according to principle of homogeneity, we know only same dimensions are added, subtracted and equated. So Px can be written as one dimensionally. Here B becomes 1 by x, and x is given as length. Length is meter, so it is L minus 1. Similarly, Bx must be equal to Ct, must be equal to 1. So Ct also is equal to 1, and C is equal to 1 by t, and t is time, so it is t minus 1. Now we all know what is A, what is B, what is C. Similarly, let's consider one more example. Example 3. Let P is momentum, V is speed, T is time, and P is given as A e to the power V plus B upon Ct. V plus B upon Ct. Find the dimensional formula of AB upon C square. It is looking difficult, but believe me, it's very easy question now. Now think again about your basic concept. Concept says only same dimensions can be added or subtracted or equated. So by knowing this, immediately you may consider that the dimension of B must be equal to V, that is velocity. Exponential, sine, they don't have any dimension. If it is having no dimension, then the dimension of B must be equal to dimension of A. By knowing this, you may exactly know B must be momentum. Now only a question of C. This power is having no dimension, so you may get C also. So let me solve accordingly. First I write V must be equal to B. So dimensional formula of B is velocity, which is Lt minus 1. I also write A must be equal to P, and you know P is momentum, which is mass into speed. Mass is m, speed is Lt minus 1. Now I got A also. The third one is V plus V upon Ct must be 1. So I may write V plus V is equal to Ct. Same dimension is added, subtracted and equated. So velocity must be Ct. So from here, C must be velocity upon time. Velocity Lt minus 1 time t, it becomes Lt minus 2. You can look at here, C becomes dimension as equal as dimension of acceleration. So in this question they were also asked, find out dimensional form, identify which of these three is having same dimension as acceleration has. You may get answer, that is C. Now you got B, you got A, you got C, you can get this one. Let us solve final one. AB upon C square may be written as A is mLt minus 1, B is Lt minus 1 and C is Lt minus 2. You may cancel few. This T minus 1 becomes T minus 2. So cancel with this. Ml. It is only Ml. Now this, second level question or third level question as per NEET, second level question as per JEE can be solved in very easy step. Now let's consider the second one, which is to establish a relation amongst various physical quantity. Second one. For this again, principle of homogeneity will valid. So let's start with one example. That is a known example. Consider time period of a simple pendulum T. Let us write small t because T may be treated as base of time. Time period of simple pendulum T depends on its length L. It also depends on acceleration due to gravity G. Question says find out a relation between them. Now, though I know the result, you also know. But if you don't know, then how you start it? They have given that time period depends on length, time period depends on G, but they have not given about the power on which it depends. We don't know. So we should consider like this. Let T is directly proportional to L to the power A. You have introduced one unknown. T is directly proportional to G to the power B. You have introduced another unknown. So now you may write time period depends on L to the power A, G to the power B. As you know, if we remove directly proportional, we have to put a constant. L to the power A, G to the power B. Consider equation 1. Now write LHS. It's a time only. Better to write M0, L0, T1. Consider right hand side. K is constant dimensionless. L and B. L is length. G is acceleration due to gravity. This. Now you may open it. You all know base are same, so we may add their powers. We don't have any mass. Now, since LHS is equal to RHS, we may equate left hand side and RHS. And if base are same, then powers will be same. So L0 t minus 1, we don't have m here, t1, and right hand side it is m0 this. Now minus 2b directly you may write 1. So b is minus half. A plus b can be written as 0. So a is equal to minus b, which is plus half. Now you know the result, a and b. Putting the value of a and b in 1. Time may be written as k L to the power half g minus half. You may write this one is a relation. This is the method only. Now since in your exam we don't need to derive the questions, it was only way to represent you to understand only. Now second example I'll consider few next level question, so that you can also think about in your exam, because in your exam you'll hardly get 1 or 2 minutes to solve these type of questions. So consider another example. There are certain limitations also. We can only derive a relation having 3 physical quantities one side. We can't derive any formula having sine or cosine or trigonometric function or exponential function or logarithm function. Only we can derive a simple way. If in any case there are more than 3, for like this example, Reynolds number you must be knowing in fluid mechanics. Reynolds number of any liquid depends on its density. It also depends on speed of flow of liquid in a pipe. It also depends on diameter of pipe, and it also depends on coefficient of viscosity of liquid. So if these type of questions are there, they must give some additional information. So for this question they have given that Reynolds number is directly proportional to D. Now we can solve, because if they have given that Reynolds number is directly proportional to D, it means they have given dimension 1. So now 8(1) is known. You have 3 unknown only, and you can solve it now. Consider let it is k times rho to the power a, v to the power b, eta to the power c, and d to the power 1. How to get coefficient of viscosity? You must equipped with all the given relations of physics. If you don't know, it will be difficult for you. So from my side, it will be better to learn to think about the simplest formula. You may have this relation f is equal to 6 pi eta rv. Sometime these can help you in this dimensional analysis. By this way you can get eta, because r is length, radius, v is velocity, and f is force. You may get eta, and if you solve this relation, you will get it is k rho vd upon eta. I am not solving because in your exam there is no need to derive things. It is only way to tell you. You must know about that if we are deriving any physical quantity having more than 3 terms right side, one side, it is not possible unless some help are not given. Now we'll consider the third heading, which I believe that the third one is more important because there are a lot of examples are based on third one. Conversion from one system of unit to other. Conversion from one system of unit to other, which I explained you, numerical value and unit, product of it is constant. So we may write numerical value inversely proportional to u. U increases, n will decrease. U decreases, n will increase. Or we may write n1 u1 is equal to n2 u2. If you want to convert from one system into another, then this formula will work. From this formula we may write numerical value in any second unit may be written as n1 u1 upon u2. Let unit in one system is m to the power a, l, that is l1 to the power b, t1 to the power c, and in second system it is m2 to the power a, l2 to the power b, t to the power c. Why these powers are same? Have you tried to explain it? Because dimensions are same in any unit. Length can be centimeter but cannot be centimeter square. Volume, that is meter per kg per meter, volume is meter cube, can be centimeter cube in any other unit. Density is kg per meter is cube, maybe gram per centimeter cube, but gram cannot be gram square. So dimensions are same in any system, only base value changes. So by these two we may write M1A, L1B, T1C, M2A, L2B, T2C. From here it is this one is a formula. Now we'll solve a few questions based on this. Very first question, I think this question is covered almost in all class of 11th from each teacher of your any school, CBSE, ICSE, state board or JEE or NEET, they all cover this example, that convert 1 Newton into CGS unit. So consider this example only. Numerical value is 1. The unit is Newton. Newton is ml t minus 2. So A is 1, B is 1, and C is minus 2. U2 is also same but having different base. N2 we don't know. Now according to that formula, this one is MKS, this one is CGS. So N2 is N1 which is 1, 1, 1, minus 2. MK's mass is taken as kg. Length is in meter, time is in second. In CGS, mass is taken in gram, length in centimeter, and time is same. If time is same, then this become 1 to the power, anything will remain 1. Now here we need to solve. So better to convert into 1 unit so that you can cut the unit and get the numerical value. 1 kg is 1000 gram. 1 meter is 100 centimeter. You may convert centimeter into meter also, gram into kg also, but it is always advisable to solve in a simplest way. 10 to the power 3, 10 to the power 2, it is 10 to the power 5. So 1 Newton is equal to 10 to the power 5, and here it is dyne. CG, or you may do, if you don't know about unit of force in CGS, you may write CGS unit. Similarly, second example is convert 1 joule into CGS. You must be knowing it. Again, it is very common. 1 joule is equal to 10 to the power 7 ERG. So again, these two questions are very important, you know. Now I'll pick few more examples to give you better understanding on this whole chapter, dimensional analysis. In any system, mass is taken as 10 kg, length is taken as 20 seconds, and 20 meter, and time is taken as 50 seconds. Then find the value of 10 Newton in that system. This one is a question. Mass 10 kg, length 20 meter, and time 50 seconds. Again, we have to use the formula N1 U1 is equal to N2 U2. Solution. Since and N1 is 10, M1 is kg, L1 is meter, T1 is second, MKS system 10 Newton, N2 we don't know, M2 is 10 kg, L2 is 20 meter, T2 is 50 seconds. So put the value now. Kg. Yeah, we must know the dimensional formula of force. It is this. Kg upon 10 kg, power 1. Meter upon 20 meter, power 1. Second upon 50 second, minus 2. it is 1 by 20, 50 to the power 2, 2500, 50 square upon 20, it is 125. So the value of N2 is 125 in new system. Similarly, they may ask several questions. Then in any particular system, mass is taken as this value, length is taken as this value, time is taken as this value. Find out the value of any maybe energy, momentum, or any other they may ask for. Convert these values. So this was dimensional analysis. Let me tell you one thing. To get complete 100% satisfaction in dimensional analysis, you must know each and every dimensional formula, and particularly dimensional formula of physical quantities of 12th standard, like magnetic field, electric field, flux, modulus of rigidity, and power, momentum, and any value related to EMI, that is EMF, motional EMF, current, magnetic field. I already told you these should be on your fingertip. Otherwise, it will be difficult for you to solve these questions. Otherwise, you will be struggling to find out the dimensional formula itself rather solving a question. Now consider accuracy and precision. Accuracy, generally we use how accurate he was, how precise he was. There is a slight difference between them. Accuracy means how close you are with the correct value, how close you are with the real value. Precision always define about the limit of accuracy, about precision always define about resolution limit, that your instrument, what is the resolution of your instrument. Accuracy close to correct value. Precision is always define a limit of your instrument, the instrument you are using to get the result. For example, let me explain by the help of this diagram. Suppose it's a target, and we have to hit it on this target. Consider three cases. These three cases. In first case, suppose you have to fire bullet on it. Suppose you have to fire bullet on it. You fired once here, you fired once here, here, and here. Consider 5 bullets. And in this case, you fired one bullet here, one bullet here, one here, one here, one here. In this case, consider 2 more bullets. One here, one here. Here, one here, one here. And in this case, you fired one here, one here, one here, one here, one here, one here, one here. This one is basically more accurate because it's close to target. All bullets are close to target except it. So it one is more accurate. Here it is, all bullets are in this range. So their limit is lying between these area. So it is more precise. And it is more accurate and more precise. Means accurate as well as precise. Now I think you are able to understand it. what is the difference between accuracy and precision. Now we'll consider significant figures. It is very important and a bit confusing too. Significant figures consider an experiment. Whenever we consider an experiment, then we'll get a result of it. I may say straightforward that result is never been 100% accurate. Any measurement is not accurate. There is certain level of errors are there in that. So basically study of those accuracy errors lies between significant figures, that which one is important figure to discuss. According to definition of significant figure, it's a combination of accurate value plus or certain value plus one uncertain value. Certain value plus one uncertain value. If we are suppose measuring any through any instrument, we are measuring length of a body through any instrument and it comes 2.33, then this 3 is basically uncertain. It cannot be correct. It is used up to 2 places of decimal. If I use up to 3 places of decimal, it may differ. It may be having 3, 1, or it may be having 3, 9, 3, 4, 3, 5, because this 3 always depends on the precision of your instrument. So this will always be uncertain, but it is always true that length must be 2.3 or more. So up to these 2 values, we may be sure that these are the certain value. It is uncertain. So significant figure of this one is 3. So there are certain rules of significant figures. Rule 1. There are 7-8 rules. Rule 1 says all non-zero digits are significant. For example, if I have a number, measured value of course 3258, then this is having 4 significant digits. 1, 2, 3, 4. Similarly, if I have 3, 1, 2, 1, 2, it is having 5 significant figures. Rule 2. Trailing zeros are not considered in significant figure. Like if I have 200, I'll say that we have only 1 significant, only this. If I have 32100, I'll say I'm having only 3 significant figures, these 3. Third, if this 0 comes between 2 non-zero digits, then it will be considered as significant figure. For example, if I have 1001, I have 4 significant figures. 1, 2, 3, 4. All are significant now. If I have 3201, again I am having 4 significant figures. Now rule number 3. In case of decimal, let me say first, if there is a non-zero before decimal, then zeros after decimal are considered as significant. For example, if I have 2.0, significant figure is 2 because there is non-zero digit before decimal. Then zeros after decimal considered as significant figure. Other example, 3.200. How many significant figures? 1, 2, 3, 4. 4 significant figure. One more example. 100.00. Now this one is non-zero digits. So there are 1, 2, 3, 4, 5. 5 significant figures. Rule number 5. In case of decimal, if there is 0 before decimal, then zeros after decimal will not be considered as significant till any non-zero value. Again, if there is 0 before decimal, then zeros after decimal will not be considered as a significant figure till any non-zero value. Like 0.0021, if we have any measured value like this, then these two numbers will be significant only. Because before decimal it is 0. If there is 0.0200, there are 3 significant figures. Now next rule. If we convert any value from one system to another system, then if we convert any value from one system to another system, then zeros will not be considered, then the significant figure will remain same. For example, 2 meter is equal to 200 centimeter is equal to 2000 millimeter. In all cases, significant figure will remain 1. Similarly, power exponents are not considered as a significant figure. If I have 2.0 into 10 to the power 5, then only these two, as per the rule, are significant. I hope you understand these 7 points of these rules of significant figures. Now, let's focus on a concept called rounding off. We often use this term rounding off. Rounding off means removing of unwanted digit. But there are certain rules in physics to remove how to remove unwanted digit. This rule starts with 5. Suppose rule 1. If the last digit which has to remove is more than 5, that is 6, then preceding digit will raise by 1. Suppose the last digit you want to remove is more than 5, then preceding digit will raise by 1. One more example. 2.338. We want to make it in 3 digits. 8 is more than 5. So it is 2.34. Rule 2. If the last digit which has to be removed is less than 5, then preceding digit will remain same. If in the above case it would be 2.53, now we want to remove it, we have to write in 2 digit only, and it is less than 5, so it will remain same. Third, the interesting one. If the last digit which has to be removed is 5, if the last digit which has to be removed is 5, then we have to look its preceding digit. Consider one more case. 2.551. Now if you remove it, it will become 2.6. Suppose you want to convert, you want to change it, it will become 2.6. Now the interesting comes. If the last digit which has to be removed is 5, only 1 is there, then a rule is interesting. Let me consider two cases. This. In both the cases, last digit is 5. In both the cases, last digit is 5. Now, if preceding digit is odd, here preceding digit is even, then odd is raised by 1. I'm sorry, odd is raised by 1, yes, and even will remain same. So again, let me revise it. In the rule of rounding off, if the last digit which has to be removed is more than 5, the preceding digit will raise by 1. If the last digit which has to be removed is less than 5, it is simply dropped. If the last digit which is 5 and after that there are some non-zero value, then preceding digit will raise by 1 in both the cases. If last digit is 5 which has to be removed, then and preceding digit is odd, it is raised by 1. Preceding digit is even, it will remain same. So this was the rule of rounding off. Now the combination of significant figure and rounding off will move ahead with what are the arithmetic operations based on significant figures. Let me write in a different way. Uses of significant figures. In arithmetic operation. This one is important. One is in addition and subtraction. In multiplication and division. Rules are different in both the cases. Here rules are different, here rules are different. The final result will contain least number of decimal places. Here, the final results here least number of significant figure. Same rule will applicable in quotient form also. Here, consider one example. If A is 3.231 and B is 8.1, then A plus B is answer will be least number of decimal place is 1 here. Here it is 3, so we'll consider 1. While removing these points, we have to think about rounding off concept. But here we are removing this and it is less than 5, so simply we'll drop it. Answer is this. So in answer, you just look, suppose there are 3 quantities, you just look which quantity is having least number of decimal places. 1 place, 3 place, you may have one more quantity having 2 places, answer must be in 1. Irrespective of significant figure. Significant figure will come into picture here. One example, just taken from previous year question of IIT. If side of a cube is 1.2 meter, find its volume. As you know, volume is A cube, it is 1.2 into 1.2 into 1.2. Solve it like a simple method. 144. Better to know square of 12. 1.2 now. Answer is 2.728. Exact answer is this. But rule says final results will contain least number of significant figure, and the least number of significant figure was 2. You have to remove the last one. It is 8. It may be 3. So it will remain 2.7 meter cube. Although in this example only one quantity was there, suppose there are 3 quantities. One is 1.2, other one is 1.32, other one is 1.7773, like this. So answer will have only least, that is 1.2, that is 2 digits. So you have to reduce it by the help of rounding off concept to make it present final answer. That's all for significant figures. Now let's study with errors in measurement. We'll study absolute error, relative error, and percentage error. As you know, I already discussed that no experiment will give you correct value. There are certain errors in each experiment. So this heading is basically just to way to find out the errors, particular errors or percentage error in any measurement. And it is very important. In any physical quantity, we must get the possible error in the measurement. It's a basic procedure in any mechanical industry. So suppose you conducted one experiment, like in your lab, you must perform series of observations to get multiple results, because one result cannot be perfect. Data maybe of you are calculating time period in your lab, or getting currents, or any force through magnetic field, or any deviation. Suppose you have taken 5 random observations. Serial number 1 you may get E1. In second time you got E2. You may get same also sometime A3. but most of the time you'll get different values. A4, A5. Now in all readings, you got different values. Then what would be the answer? Answer will be sum of these values upon number of values. That is the mean value. But that value is not perfect, may not match any of these 5. Then what should be the way to write answer? Then this absolute error, concept absolute error, relative errors and percentage error comes into picture. Mean value. A mean. It is A1 plus A2 plus A3, A4, A5 upon 5. Now what is absolute value? Delta A. Absolute values, basically absolute is a difference between mean value to individual value. It's a difference between mean and individual. So absolute of 1 is mean minus this. Absolute of 2 is mean minus 2. Absolute of 3 is mean minus 3. Absolute of 4 is mean minus 4. Absolute of 5 is, you may get some negative absolute also, because suppose for example it is 4.5, 5.3, 5.2 like this, and mean value is 5.4. So 5.4 minus 5.5 will be minus 0.1. So you may have positive value or negative value, but we only consider modulus of it, deviation of it. So now mean of absolute value is and final answer is A is equal to A mean plus minus. This will be the result. This will be the result of your experiment. Now, so delta AM is absolute value. Absolute value is the difference between mean and individual. What is relative error? It is absolute value upon mean value. What is percentage error? It is relative error into 100. Now there are certain rules to find out relative error, percentage error of any physical quantities. Uses of error analysis in arithmetic operations. Uses of error analysis in arithmetic operations. First, in addition and subtraction. Like if you have any quantity A which is represented by this, B which is represented like this, and You want to calculate x, which is a plus b, and y, which is a minus b. Now, what will be delta x? What will be delta y? So, rule says, make it very clear, in addition and subtraction, absolute error in the final quantity is the sum of absolute errors in the individual quantity. Is the sum of, in case of this also. So delta x is sum of absolute errors in the individual quantity, and delta y is also same. No minus sign here. You must read it carefully. In the absolute error in the final quantity is the sum of absolute errors in the individual quantity. Now, second heading says, for in multiplication and division, again consider A is a plus minus delta a, b is b plus minus delta b, and you want to get it x a b, y is equal to a upon b. Here rules, this rule was for absolute errors. Now here rule is different, and in multiplication and division, rule says relative error, not absolute error. Relative error of the final quantity, relative error or percentage error, because both are almost same into 100. You can convert relative error into percentages by multiplying 100 only. In the relative error in the final quantity is the sum of relative errors of the individual quantity. Relative error of the final quantity is the sum of relative errors of the individual quantity. That is, delta x upon x, relative error in the final quantity, is the sum of relative errors in the individual quantity. Relative error in the final quantity is the sum of relative errors in the individual quantity. Or percentage error in the final quantity is the sum of percentage error in the individual quantity. And it is here also. Here also. Now, third rule. For physical quantities raised to power or quotient, let x is equal to a to the power m, b to the power m, y is equal to a to the power m upon b to the power n. Here also rules are almost same, because plus rules are same for plus minus, multiplication, division, same with here also. According to this, relative or percentage error of the final quantity is the quotient power times relative, sum of the power times relative or percentage error in the individual quantity. Here also. And similarly for percentage. Here, to get x, you need delta x also. So first calculate x. I'll consider few example, and then put those x here. All this value will be known. Delta x can be easily calculated. So error and uses of error analysis in arithmetic operation is having three headings: in addition, subtraction, multiplication, division, and for physical quantities raised to some power. Now I'll consider few examples. Suppose we have to find out these 4. Means there are 4 questions from 1 question. Here, let x is equal to a plus b. It is 2.0 plus 1.0, 3.0. Delta x is equal to delta a plus delta b. It is 0.2 plus 0.1, 0.3. So answer is x is equal to 3 plus minus 0.3. For this, let y is a minus b. A is 2.0, b is 1.0. So answer is 1.0. Now delta x will be exactly same like the previous case, 0.3, and answer is delta y. Y is 1.0 plus minus 0.3. Now consider this. Let A, capital A is AB. 2.0, 1.0. It is 2.0 only. Now delta A upon A is delta A upon A, delta B upon B. It is 0.2 upon 2.0, 0.1 upon 1.0. Here I would suggest to use percentage error. If I use percentage error, it will be easily calculated. Otherwise, during examination time, you may start thinking about significant figure, which will kill your time, which may lower your confidence. So it will be better to use percentage error. So percentage error here, it will be multiplied 100. So 0.2 into 100 is 20. 10 upon 1. So it is 20. So delta A is 20 into A upon 100. A is 2.0. It is 4.4. It is 0.4. So A is 2.0 plus minus 0.4. Now the last one. Let me solve it here. Let B is A upon B. B is 2.0 upon 1.0. Answer is 2.0 only. And delta B upon B, delta A upon A. Let me get percentage error. Now you can easily understand quantities are same. So you'll get same. A value of B is also same as A. So delta B you'll get as 0.4 and answer is 2.0 plus minus 0.4. Fortunately in this case you got same answer. You may not get same answer in different cases. This was example 1. Now I'll consider one more case. it is given x is a to the power 3, b to c to the power 3, and percentage error in A is 1%, in B is 2%, in C is 1%. Then what is maximum percentage error in X? Now, as per our rule, percentage error in X is power times percentage error, sum of the power times percentage error of the individual quantity. It is given as 1%. It is given as 2%. It is given as 1%. So it is 3%, 4%, 3%. So total percentage error is 10%, and it is the answer. Now we'll consider one more example, last example of this chapter. It is always better to pause it and then write it down. Because it's a crash course, we can't hold it down for more time. If momentum of a body is increased by 100%, keeping its mass fixed, then find percentage by which its kinetic energy changes, or find out the percentage change in its kinetic energy. This question is slightly confusing. You cannot use error analysis in this, because error cannot be 100%. If it is 100%, this will not be error. It will not be an error, it will be in fact a mistake. So error analysis will not be valid. Since kinetic energy is P square by 2m, so delta K upon K into 100 cannot use. You cannot use. We'll use simple method. That is final kinetic energy minus initial kinetic energy upon initial kinetic energy into 100. Now, since kinetic energy is directly proportional to P square, and final kinetic energy is, let initial kinetic energy is P square by 2m. P initial, that is P square by 2m. Final kinetic energy is P final square upon 2m. And final P is P initial plus 100% of P initial. So P plus 100 upon 100 into P. 100% of P, so must we multiply 100 upon 100 into P? 100% of P means same value again. It becomes 2P. So P final is 2P. So this 2P is square upon 2m. It becomes 4 times P square by 2m. It is 4 times K initial. Check it. Now K final is 4 times K initial minus K initial upon K initial into 100. It is 300. So percentage by which kinetic energy changes is 300. Thank you very much. Thank you.